Hello. Okay, so we'll wait for a few minutes to join others, then we'll start after 2-3 minutes. Okay, so today we will discuss on these three topics. So one is differential equations, and the second one is first order, differential equations, which has the order of the differential equation in one, and then the exact differential equations. Okay. Yeah. So to begin with, what is a differential equation? So if I say it briefly, then the differential equation is a relation between an unknown function and its derivative. Okay, so differential equation is nothing but a relation, and it's a relation between an unknown function and its derivatives. Okay, derivatives. I mean how? So if we let's say Newton's law of cooling. So what it says, Newton's law of cooling. So it says that the rate of change of temperature is proportional to the temperature difference between it and that its surroundings, right? I mean, that you can write in terms of, so I mean, if I write rate of change of temperature, which is proportional to the temperature difference. I mean, I'm not writing it here precisely, but yeah, this is a temperature difference. So what is the meaning of proportional? So the rate of change means dt small t. This is here, t is the temperature which depends on time, that will be proportional to some t minus t naught. Okay, where t is the temperature of the body at time t and t naught is the temperature of the surrounding. Okay, and that implies dt small dt will be equal to some k times t minus t naught, where k is a real number, real constant, the proportionality constant. So this is how you see here you get a differential equation. Okay, so similarly for let's say if you have a wave equation, I mean the displacement of wave, so that you can derive or you can model that wave using this something, this is called partial differential equation, then it will come in this, so which is not I think done in your course, so let's not do that. So I think you have this f equal to ma, this step when you have this law, I mean Newton's law, so then also you get some second order differential equation, right? So because f will be nothing but d2, you can write this a as d2x dt2, right? So then you will get a differential equation here also. So the differential equation, I mean we call these are as ordinary differential equations. So this is as ODE, different ordinary differential equations. Okay, so mainly here we will be doing, like we first we will check how to find out the order and degree of differential equation like this. So let's say if you have a differential equation like d2x dt2, x is a function which is, I don't write always xt, but it is xt. Okay, plus let's say you have x is equal to 0. This can be a differential equation. Okay, what will be the degree and order of the differential equation? So what it is telling, so here x is unknown variable, right? Sorry, t is unknown variable, x is known, means when you know x, so you know t, then x is known, right? So what, excuse me, so this is a mistake I'm making. So here the known variable and unknown variable, so known variable is, I mean t is known variable, so some problem is here. Yeah, so here x is unknown variable, t is known variable, right? Because once you know t, then x is known. That's what meaning of unknown and known, right? I mean x depends on t and t is a known variable, then x is known, but otherwise x is unknown. I mean that's how x is unknown and t is known. So you will have a like, so that's what I have said here. The real differential equation is a relation between unknown function, here unknown function is x, and t is the known variable, and the relation between, here you have the relation between unknown function and its derivatives. Okay, the relation can be like this, or it can be like x time d2 x dt2 plus dx dt is equal to 0, or it can be dx dt whole square equal to 0. This also is a differential equation. That's all, right? So now what is the degree and order of differential equation? Okay, the order of the differential equation is defined to be the highest order derivative it contains. So let's say I denote it by 1 and I denote this 1 by 2. So then what happens if you have, let's say, for first one, what's the highest order derivative? It is d2 dx2, right? Highest order derivative, and the derivative only one for one term is there, and that is twice, right? So two times you derive you have done derivative, right, to with respect to t. So the highest order derivative is 2, right? So the order will be, highest order derivative means uh, the order will be order of the differential equation of 1 is 2. Okay, so in and what is degree? So degree will be the power to which the highest order derivative is raised. So you have here in the first one, you have only one derivative itself. So and the highest order, so d2x dt2 to the power 1, you can think of it like this. So then the degree, that's how degree will be 1. And what about in the second question? So second one you have d2x dt2. So highest order derivative is, so what are the derivatives? So derivatives are d2x dt2 and dx dt, right? So you have only two derivatives here, but the highest order derivative will be this one. So this will be, so it will be then 2. The degree will be, sorry, order will be 2, and degree will be the highest order, the power of highest order derivative. So you have d2x d2 to the power 1 you have, and d2x d2 to the power 2 you have. Although you have here here it is 2, but the highest order derivative is d2x d2, and the power of that is 1, so degree will be 1. So this is how, let's say, if you have to find out order and degree of, like, let's say this one, d2x dt2 plus dx dt, so dx dt to the power 3, d2x dt to the power 2, and 3, and let's say 4 plus y plus x equal to 0. So then also, you know, right, what is the highest order derivative here is 2, so the order will be 2, and degree will be the, it will be 3. So this is the power in the highest order derivative. Okay, so degree of a differential equation is defined as the power to which the highest order derivative is raised. So yeah, so this is a more or less, I mean, one like basic idea of what is order and degree of a differential equation. So here, let's say now one question is from your assignment is d2y dx2 is equal to square root of 1 plus d cube y over dx cube. So then how you solve this one? So what will be the order and degree? Order and degree. So what will be the order and degree? So the thing is, it is said that, so you have to always convert it to non-fractional form. If you have a fraction type this, so you have to so change this one to, you if you square it, then it will be it y dx2 to the power 2 is equal to 1 plus d cube y over dx cube whole square. So if you have this, then now you know the what is degree and order. What is degree? Then degree will be 3 and order will be the power of the highest, sorry, order is 3 and degree will be order, the exponent to which the highest order it occurs, so it will be 2, right? So it is one of your assignment question, so you can do like this. Okay, so always if you have, let's say you have like a dy dx is equal to 1 plus d2y dx2 to the power 9 over 10, let's say. Okay, so then what you will do, you have to make it non-fractional form, in the non-fractional form. So just do it like this. If you take it over 10 to the power 10, then it will be 1 plus d2y dx2. I mean, let's say it is like this. Okay, let's say it is like this, 1 over 10. Then okay, let me write it properly. Otherwise you have to, if you do like this, then it will be a little different way also you have to do. So that's why I'm giving it in a way you can understand also, and it will be a little bit easier. So 1 plus uh, d2y dx2 to the power 1 over 10. So it will be then like this. Okay, so what will happen then? So then you have to, the what will be the order and degree? So order is 2 and degree will be 1, right? So that's how we have to do. Okay, so next come to this uh, second question. Let's say another question you have. So that is yx is equal to, is written that yx equal to c1 c2 sin x plus c3 e to the power x. So this is a function which is having three arbitrary constants. Okay, you have three arbitrary constants. So they are c1, c2 and c3. So what will be the, it is asking that what will be the order of differential equation which this yx solve. Okay, so yx is a general solution. It will be, you know, all of you know, I hope this is a general solution. General solution type. What is general solution? All of you know. So if you know, then what will be, and if this one is a general solution of a differential equation, then the order of the differential equation we have to find out. So what you do then? So to do that, so you just simply take derivatives and you check. So if you take y dash x, so then it will be minus c1 sin x plus c2 cos x plus c3 e to the power x. So e to the power x remains unchanged, and y double prime x will be minus c1 cos x minus c2 sin x plus c3 e to the power x, right? So anyway, we have to find out what is the differential equation y which y solve. Okay, right? Okay, so to do that, if we take y double prime plus y, that will be 2c3 e to the power x, right? 2c3 e to the power x. Okay, so yes, now what you have to do to get, so what you can write here from here, that c3 is equal to y double prime plus y, right, over 2 e to the power x. So that is 1, And another you can get from y minus, so what you can, so you can put this c3 here in the c2 and c1. If you can find out, then things will be fine, right? Okay, let me do on another derivative. So y triple prime x will be c1 sin x minus c2 cos x plus c3 e to the power x. So if you now what we can do is y triple prime x plus y prime x, right? That will be also 2c3 into the power x. So anyway, from these two, this and this, what you can say, y triple prime x plus y prime x is equal to y double prime x plus yx. So what's the meaning of this? The degree, sorry, order, degree is always, degree will be 1, order will be is equal to 3. See, that's what we got because we started with a function which has three arbitrary constants, right? You have three arbitrary constants, so it should satisfy a differential equation which has uh, the which has degree 3, sorry, order 3. Okay, so so the general statement is a general solution of an nth order differential equation contains n arbitrary constants. Okay, so that's why here also you see that. So now let's say if you want to find out a general solution of a differential equation like this, 1 plus e to the power x over y times dx plus e to the power x over y 1 minus x over y dy is equal to 0, right? So so if I write like this, then it looks a little weird, so we can change it by doing like this. See, first of all we have always x over y, this type of thing. So now, so all the things are common is x over y, and that is making power and 1 minus x over y to the power x over y, like that. So if you take x over y is equal to v, let's say x over y equal to v, then x will be y times v, and then you can write dx dy will be v plus y times dv dy, and then dx dy you have is equal to like this. So the the given differential equation will change to 1 plus e to the power v times dx over, let let me write it this dy, divide by dy, or I mean take in such a way that it will be dx over dy plus e to the power v 1 minus v is equal to 0, right? Now everything you have to change it to, you have changed x equal to y times v, so you have to change to v and y. So 1 plus e to the power v plus y times dv dy plus e to the power v 1 minus v is equal to 0. That implies v plus y times dv dy is equal to e to the power v minus 1 over 1 plus e to the power v, right? That implies y dv dy is equal to the power v minus 1 e to the power v plus 1 minus v. So what does that give? That gives you e to the power v times v minus e to the power v minus e to the power v times v minus v over e to the power v plus 1. So what does that give? So y times dv dy, y times dv dy will be dv dy. So e to the power v, this will cancel out, and minus of e to the power v plus v over e to the power v plus 1. That implies e to the power v plus 1 over e to the power v plus v. I am just taking it in one side, dy by y, and now you can see this can be written as e to the power v plus v over e to the power v plus v is equal to minus dy by y. So if you integrate this, this will give you ln of e to the power v plus v is equal to minus of ln y plus some ln of constant you can take. That will give you y times e to the power v plus v is equal to constant. That implies y times e to the power x over y plus x over y is equal to c. Right? That implies x plus y times e to the power x over y is equal to c. So this will be the solution of the system we started with here. So yeah, so this is if you have a equation like this, like instead of 1 plus e to the power x over y, some other function 1 plus tan of x over y, and like most of the places we were seeing x over y or y over x, you just take x over y is equal to v, or at least if you can separate that too, because here also you can write dy over dx is equal to some function which is which looks like f of x over y. I mean, what I want to say is, what I mean here is dy dx is equal to, let's say, if you have dy dx is equal to f y over x type of function. So try to take y over x equal to v in those cases. Okay. So all the cases won't be solved, but yeah, most of the cases you can solve by. So that's what you will see in the Yeah, sorry for the internet connection issue. So I resume the class here from here. So yeah, so the so what we were doing is this type of, if you have this type of differential equations, then what we can do is can take y over x is equal to v, and I can transform the equation to make it make our life little easier. Okay, so next we will do another question. So mainly I am doing now from the assignment questions. So sometime I give my own question also from some other book and all, textbook. So yeah, so let me check. So yeah, now the second question is like this. So if you have 2x plus 5y plus 1 times dx minus 5x plus 2y minus 1 times dy is equal to 0. So then how you solve this? Uh, so how do you solve this one? Okay. So you can see that it's not like simple equation like x dx minus y dy is equal to 0. So when this type of equation are there, then what you do, this you divide by xy, then it will be dx. Sorry, not like this. Let's say you have y dx and x dy. So you divide by xy, then it will be dx over x minus dy over y is equal to 0, or dx over x is equal to dy over y. That if you take integration, then it will be ln x is equal to ln pi. In the solution you will get easily. So here it is not like that. You cannot do it easily. So that you have to, what you have to do it, you have to solve in such a way that, so this becomes much more easier. Okay, so dx over dy, mainly dx over dy or dx over dy, what you get is 5x plus 2y minus 1 over 2x plus 5y plus 1. So that implies, I mean, or you can write as dy dx is equal to 2x plus 5y plus 1 over 5x plus 2y minus 1. So this is a general type of, when this dy dx is equal to ax plus by plus c and dx plus ey plus f, some two plane you have. Okay, then what we do is we transform this x to some y plus, sorry, x to x plus h and y to y plus k. This type of transformation we do. So if you do this type of transformation, and then what will happen, this dx over dy will be dy over, sorry, dx over dy will be dy over d, dx over dy, capital dx, or dy over dx you can write as dy over dx. That won't change. Okay, The only thing will change is, so what you can write is from here. So from here, what you can then write, dy over dx is equal to 2x plus 5y plus 2x plus 5y plus 2h plus 5k plus 1 over 5x plus 2y plus 5h plus 2k minus 1, right? So now what we'll see, that see h and k are arbitrary two constants we assumed, we started and we assume that x and y are two constant, x y are the changed variable, capital X capital Y. So what we will make, so we choose hk in such a way that 2h plus 5k plus 1 is equal to 0 and 5h plus 2k plus 1 equal to 0. We'll always fix hk in such a way that these two coefficients, whatever the equations are coming, whatever the terms are coming, those will make it 0, and we can show that this, then what the solution will be, h equal to 1 by 3, k will be minus h, so it will be minus 1 by 3, and thus you will get dy over dx, you will be getting 2x plus 5y over 5x plus 2y, right? Because these two terms are 0, this term and this terms are 0. So now it will be very easy. So now you can see that this is nothing but 2 plus 5 times y by x over 5 plus 2 times y by x. Now you know already, I have shown that this, you have to now choose y by x equal to v, then you proceed with like this, the first one. Okay, so you pause for some time and check whether you can ever you understand this while watching the video. Okay, yeah. Now the will come to the whether your differential equation is exact or not. So what is the meaning of exactness of a differential equation? So that we'll see. So if you so let's say if you have a differential equation like this, m dx plus n dy is equal to 0. Let's say you have this. So then the meaning of exactness will be like del m del y should be equal to del n del x. Okay, so if this is so, then the differential equation is exact, and in that case there is a theorem that if this happens, then any this type of differential equation can be written as, I mean, m dx plus n dy will be some d of a function f. So what's the meaning of that? If so, first of all, if this occurs, then it will happen. So if this happens, then this, and this, when this one is equal to this, so this implies df equal to 0. So if the function exists reasoning, you don't know explicitly what is the function for each differential equation, it will change, but there exists a function such that this, and that implies f will be equal to constant. All right, so that's why when it is exact, so it will be very easily you can find out the by easy some easy manipulation you can do, calculation, straightforward calculation you can do. But when it is not exact, then it will be difficult. But so non-exact equation you can make it exact also, that those processes are also there. So so let's say this equation, whether it is exact or not, cos y plus y cos x dx plus sin x minus x sin y dy, that is equal to 0. So find whether check that whether this is exact or not. So what I have said, for this type of differential equation, so this is how we can check exact or not, right? So now for this one, so if you compare with the mdx, m is this and n is this. So what will be del m del y? So I hope all of you know what is the meaning of del m del y. Means if you have a function of two variables x and y, let's say, then del m del y mean you are doing partial derivative with respect to y. And what is the meaning of that? So you keep x fixed, x is fixed, then you are derivative doing derivative with respect to y, that's all. So here it will be del m del y means del m, sorry, del y of cos y plus y cos x. So x is fixed. So first component you don't have any x, so del y of cos y means minus of sin y. And the second component x is fixed. X is fixed. So cos x will be fixed. So cos x will behave like a constant in this case. So only the derivative will be with respect to derivative will be with respect to y and to the function which will act on the function y. And that means del y of y means if you take derivative of y, that is 1. So plus then cos x. Similarly, if you do del n del x, that will be first sin x will be the derivative of sin x is cos x minus x times sin y means minus sin. And you can see this del m del y will be del n del x. So it is exact. So exact differential equation, right? So this is the exact differential equation. So now, as I said, I like this was a question from your assignment, but can you tell me that whether there exists a function f such that d of f? So here the m dx plus n dy, then it should be some d of f. So find out f, find f. So how you do that? So you have, and I'll be writing here also, m is m is cos y plus cos y plus y sin x of y cos x, y cos x. N is equal to sin x minus x sin y. So think for some time, then we'll do also. We'll do. Okay, so, how do you find this f? So whether, as I said, there exists a f. So is it really it exists? So for this equation, at least we will see. Okay. So m is this and n is cos y plus y cos x, and n is sin x minus x sin y. Right. Okay. So okay. So cos y plus y cos x times dx, okay, plus sin x minus x sin y dy, right? So that implies, so that is equal to cos y dx plus, if I take sin x dy, okay. So how do you find this f? So no, it's not always easy to find this function, but it, the theorem said it exists. So I am trying to find out whether we can get that f easily. So it is not always you can find easily. Okay, but let me try. So this plus y cos x dx minus x sin y dy. Yes, so okay, can take y dx x dy cos x. Okay, so here this is a little bit involved, I think. So what we usually do, we take integration when the differential equation is exact. So we take integration, and so in here mainly we have to manipulate to get it as a form of this d of something. So that's why I was starting with this cos y dx and sin x dy, but that is not a good way to do, because you have cos y and sin x. So in that, and that's why it's not good way to do that. So you may have to do this cos y minus cos y dx minus x sin y dy. Okay. So so anyway, we can, I think we can do now. It's now I got it, the thing. So cos x dx plus sin x dy, right? So if you do that, most probably I can do this. So the what is will happen? So can we write this as x x sin y, I guess. No, no, not x sin y, x cos y, right? D of x cos y, and plus d of, here what you can do, y sin x, right? So what I will see, this is nothing but d of x cos y plus y sin x. So that is the function d of f I was looking for. So the solution for this differential equation, given differential equation, will be x cos y plus y sin x equal to 0. I mean, it's the exact solution, exact differential equation. So you can always write as df, and f equal to constant will be a solution always, right? So you understand this, right? So how this get is d of x cos y. The one only I will tell you what, like how it it is coming. So d of x y, it will be first dx time cos y, I mean, or cos y times dx, and plus x time d of cos y, that is nothing but minus sin y dy. So that will be minus x sin y dy. That's how you get cos y dx minus x sin y dy. So that's how the other term also, and you can write always the differential equation. So it might not be always easy, but it can, you can get a function like this, which will be like the by which you can write the differential equation in exact form. Okay, so there are many techniques to make a differential equation exact if it is not also exact, right? So that also we'll see how we can do that. So let's say you have a differential equation like let's say this, you have 4x square y cube dx, okay, and plus y times dy is equal to 0. So this differential equation is not exact. So this differential equation is not exact, right? So you can see this, this is m dx plus n dy is equal to 0. So this m will be del m del y. You can, if you write del m del y, then that will be 4x square times 3y square, which is nothing but 12x square y square, right? Not x square. So yeah, 12x square y square, and but what will be, whatever del n del y, that will be 1. So 12x square y square for all xy is not equal to 1, right? So it is not exact. So there will be lot of differential equations which are not exact, right? So there are exact differential equation and non-exact differential equation. However, you can make the exact differential equation, non-exact differential equation as exact differential equation. So by multiplying some function or somehow you can do that, usually by multiplying some function, because say del m dx plus n dy is equal to 0. This solution of this and a non-zero function, this, let's say some f times m dx plus n dy, the solution won't change, right? You know, so if you multiply by a factor which will make, now if you can show that this differential equation is exact, then this equation will have a solution. We can, you can write as a compact form some z d of gx, then the solution will be gx will be equal to constant, and that solution will be for also this solution for this equation. So okay, so we'll see. Let's say the, you want to for this equation, let's say y dx plus y square minus x dy is equal to 0. Okay, so here m is y, so del m del y will be 1. Del n del x, what will be del n del x? Del n del x will be only derivative of minus x, which is minus 1, right? So of course 1 is not equal to minus 1 in any case, so it is not exact. So how we will make this one exact? So there is one way is, you take del m del y and difference, take difference between del m del y and del n del x, that will be 2, right? And you divide by
1 over n. Okay, 1 over n times del m del y minus del n del x. If this is equal to only function of x, if it is only function of x, so in this case what it is coming, n will be 2 over y square minus x. So it is not only function of x, so you cannot do it in this way. So another way is 1 over del m times del n del x minus del m del y. This is a function of only y. So what is this? 1 over m is it is 1 over m means 1 over y times del n del x is minus 1. Del n del y is minus of minus 1. So minus of 1. So that is nothing but minus 2 over y. Yes, it is a function of only y. So if this is so, what you can do, there is something called integrating factor. So the factor I said, see, if you can multiply by a factor f, so that factor what you can find out, there is something called integrating factor. You can write the e to the power minus 2 over y, integration of 2 over y dy. So that is nothing but e to the power minus 2 integration dy over y. That is nothing but e to the power minus 2 times ln of y, that is nothing but e to the power ln y to the power minus 2, which is nothing but 1 over y square. So what is this? It came out something by which if you multiply the differential equation, given differential equation, that will be exact. It was not exact initially, right? It was not exact. It is not exact. So but if you multiply by 1 by y square, we will see also it is exact. So how this the differential equation in 1 over y square y dx plus x square minus y, or y square minus x, something was there, y square minus x, y square minus x dy is equal to 0. And first of all, let us check whether this is exact. So this how it is exact. So it is coming like dx of y plus 1 minus x over y square, right, dy is equal to 0. So if you take m dx, m will be 1 over y, m is 1 over y, so del m del y will be minus 1 over y square. Del n del x, n is nothing but 1 minus x over y square, so del n del x will be minus 1 over y square, so exact. So del m del y is equal to del n del x, so exact, right? So if it is exact, so what you can do, it is exact. So now you'll try to find out what is that d of, can you write this whole quantity as d of some function? So how you can write, so dx over y plus 1 minus x over y square dy is equal to 0, sorry, not equal to 0. So that I want to write how one can write as d of something. So dx over y minus x over y square dy plus dy, right? Can't you write this one as d of x over y, right? So first one will be d of x, and second one will be x times d of 1 by y, which is minus 1 by y square plus d of y. So that is nothing but d of x over y plus y. So your solution will be always x over y plus y is equal to constant for the given differential equation. The differential equation we started with. See, we take the one differential equation which, for which this del m del y is equal to 1, del n del x equal to minus 1, so which is not exact, but we found out, we know one way to do this. So you multiply, you calculate these quantities, and if it is only function of x or only function of y, then the integrating something called integrating factor, if you multiply by that integrating factor, it can become exact equation, and the solution of that will be the solution for the main equation also. That's all you need to know for this integrating factor and all. Okay, so we'll do few more question on integrating factor, then we'll move. So sometime you may find out that the differential equation for a homogeneous type of differential equation like this, y square times dx plus x times x minus y dy is equal to 0, which is given like this. So first of all you can find out del m del x del n del y. Those will not be, we will not find, this is del m will be y square, so del m del y will be 2y, del n del x is equal to del n del x will be 2x. So 2x cannot be equal to 2y unless x equal to y, but that is not always true. So del m del y is not equal to del n del x always. So that's why it is not exact. So differential equation is not exact. So now what you can do? So there are multiple way to do. So first of all, make it del m del y minus del n del x. What will be that? And divide over n. Okay. So what has to be this? So this has to be only function of x. So what is this? So 1 over x times x minus y times del m del y minus del n del x is 2y minus 2x, right? So that is nothing but minus 2 over x. Yes, it is only function of x. So in this case, what you can do, you can take integrating factor as e to the power minus integration 2 over x dx, and that will be nothing but x square. Sorry, 1 over x square, right? 1 over x square. This is one you can do, like one you can do in this way. Another also you can see 1 by m times del m del y, sorry, 1 by m times del n del x. Let me correct it. Yes, del n del x minus del m del I. So this has to be, if it is a function of only y, so will this be a function of only y? So it is 1 over y square times, anyway it will be something like 2x minus 2y, right? So it cannot be only function of y. So in this case, this will work, this will work when if you multiply by 1 by y x square, then this will be exact and you can get it. So I'll say another way also, this, if you try to find, try to do is mx plus ny also. What is mx plus ny? What will be mx plus ny? Mx plus ny will be x y square y square times x, which is x y square, plus x times x minus y times y. So what will be this? X y square plus x square y minus x y square, which is nothing but x square y. So what you will see, this x square y, I mean 1 over mx plus ny will also be a indicating vector, means 1 over x square. So you can check with both this. If you multiply by 1 over x square, also if you multiply by 1 over x square times y, or in more general way I will say this 1 by x square y to the power any m, where m is greater than equal to 1, you will see that is also, I mean also you can check for any m, that also will be a indicating factor, an indicating factor, because you multiply by something and then it becomes exact. Once you multiply by to a exact differential equation by some function, so then it will, again it will be also exact after multiplying. uh, Once you multiply and make it exact, so this will be exact, right? So if you multiply by 1 over x square, also if you multiply by 1 by x square times y, that is nothing but 1 by y times 1 by x square, so that is already got exact, so it will be not a problem. Okay, so you will see in the both cases you will see get the same answer. So let me also do, because you'll see this, you have the differential equation is y square times dx plus x times x minus y dy, that is equal to 0. What we got, one is 1 by x square, 1 by x square, one is 1 by x square times y. So if you multiply by 1 by x square, so it will be y square over x square dx plus 1 minus y by x dy is equal to 0. That implies y square by x square dx minus y by x dy plus dy is equal to 0. That implies, anyway, what you have to have this d of, first of all, let me check whether d of this one will work. So yes, see, first of all you can take y out and take it, write it like y dx minus x dy over x square plus dy by y is equal to 0, right? So in that case we will get, this is nothing but now d of y by x, you can write the dy by x like this, and d of ln of y is equal to 0. That implies y over x plus ln of y will be equal to a constant, arbitrary constant, indicating constant. So that will be the solution of the given differential equation. Again, if you multiply by x square by y also, you can take y common and you can again make it like this. So it will be, again the solution will be same. Okay, so it is easy to check. I leave it to you. Now let's find out a general solution for a differential equation like this. Let's say you have like this, dx dy plus x is equal to the power minus tan inverse of y. So the hint is, I will be writing hint here. So if you have dy dx, sorry, dy dx plus py is equal to some q function. p and q are the function, two functions which depends on x, and p depends on x, q depends on y, or q depends on x and y. That's not a problem, but p has to only depend on x. Okay, so in that case the integrating factor will be integrating factor, which I already told about, that integrating factor is the function by which you multiply the given differential equation and make it exact, make your life easy to obtain the solution. Integrating factor will be e to the power integration p times dx. Okay, this is the hint for this hint for solving this equation. So how you can do it? Okay, so let first of all let us change the differential equation. Sorry, not change. I mean rewrite the differential equation as dx dy plus, it was dy dx plus py. So for same thing will happen for dx dy plus px is equal to q. In that case, p has to be a function of only y, and integrating factor again it will be e to the power integration p dy, not dx. Okay, like this. So it here in this case then x time, so 1 over 1 plus y square times, sorry, times x, yes, is equal to 1 by 1 plus y square e to the power minus tan inverse y. Okay, so what is be the integrating factor here? Then integrating factor will be e to the power integration 1 over 1 plus y square dy, right? That is nothing but e to the power tan inverse y, right? So now we multiply by e to the power tan inverse y, tan inverse y dx dy plus e to the power tan inverse y times 1 over 1 plus y square x is equal to 1 over 1 plus y square, right? If you do this, then it will be e to the power tan inverse y dx plus e to the power tan inverse y over 1 plus y square dy, and x also you write, that will be equal to dy by 1 plus y square, right? So can you write it in a better way? So if you write this in a better way, so this you can write as so dy, you just multiply it by dy, and dx is as it is. Okay, so can't we write this quantity as d of e to the power tan inverse y times x, right? That's all. Then t of this is tan inverse y, because derivative of tan inverse y will be 1 by 1 plus y square. And here you see d of first component, if you, sorry, d of second component first you take, then this one will e to the power tan inverse y times dx, that is first one, and then x keep common, that is x, and then d of e to the power tan inverse y means e to the power minus tan inverse y times d of tan inverse y will be 1 by 1 plus y square and then dy. So that's the second one. Then we get similarly here. So that implies d of e to the power tan inverse y x time tan inverse y minus tan inverse y will be equal to 0. That implies x e to the power tan inverse y minus tan inverse y will be constant. So like this you can do. So similarly, if you have to do, let's say this question, dy over dx plus 3y over x is equal to the power x over x cube. Okay. So the integrating factor in this case will be e to the power, so dy dx plus function times y, so that will be integration 3 over x time dx is equal to e to the power ln of x cube is equal to x cube. Okay, and then you have to multiply by x cube, so x cube times dy dx plus 3x square y is equal to e to the power x. So if you multiply by dx and if you take integration, I mean, the first of all you can write this in this side as x cube y, right? And that will be equal to uh, e to the power x d of e to the power x, because the derivative into x is into x. So that implies x cube y is equal to e to the power x plus constant. This will be a solution for the differential equation. Not this, I mean for the differential equation, this also. This implies this. So it becomes very easy when if you know integrating, how to find out the integrating factor, and then mainly the multiply by the integrating factor. Okay. So in the same way, you can show that dy dx plus 2xy is equal to, let's say you have x. So how you do that? Then integrating factor will be e to the power integration 2x dx. 2x dx mean e to the power x square, right? E to the power x square will be the integrating factor, and then you can write as d of y times e to the power x square is equal to uh, this e to the power x square times x dx, right? Now if you take integration y times e to the power x square will be, can write as integration of 1 by 2 times e to the power x square times d of x square, right? So if you do that, this will be half e to the power x square only plus c, right? The solution you can write in a more precise way will be y will be half plus c times e to the power minus x square, right? So this is how you can do the function the solutions uh, which you can solve using integrating factors and all. Okay. So now let's have a differential equation like this: y dx minus x dy minus x square plus y square times dx. That is, let suppose this is equal to 0. So how to solve this one? So why I'm telling, I'll let you know at the end. So if you see, sometimes we do a divide and multiply. So here if we divide x square plus y square, then x square and x and y both has to be non-zero. So we have to assume first that x and y are non-zero. Then what you can do, this y dx minus x dy over x square plus y square minus dx will be equal to 0. And from there what you can get is tan inverse y over x. This one you will get tan inverse y over x minus, I mean, d of tan inverse y x. So a minus x equal to c constant. So how if you do this tan inverse tan inverse y over x minus x equal to constant, this I mean this is a solution. Now you have assumed that x is not equal to 0 and y is not equal to 0. So if x is not equal to 0 and y is not equal to 0, then only this will follow. But what about the now the solution will be, now the solution will be y is equal to x time tan inverse minus c minus x, right? So if minus c minus x, there also they has to be also not equal to uh, 2n plus 1 times pi by 2. I mean, if they this minus c minus x is equal to 2n plus 1 times pi by 2, then also this tan inverse does not exist. Tan inverse, I mean tan inverse exists, but I mean it will blow up. Tan of that pi by 2, that will that blow up, right? So tan here y is equal to x times tan of, not tan inverse. So minus c minus x, that also has to be not equal to 5 by 2, that 5 by 2 multiplication of pi by 2, which multiply odd multiplication of 1 by 2. So if you multiply like odd multiplication of 5 by 2, if minus c minus x is equal to odd multiplication of 5 by 2, then also it is not defined for any integer n. Odd is, you can write as 2n plus 1 times 2n plus 1, you can write any odd number. So the domain now, the domain assumption based on x is not equal to 0 and both y is not equal to 0, or at least one of them. If you start with x is not equal to 0 also, then also it will be fine, right? One of them at least not equal to 0 it has to be. So let's say we start with x not equal to 0, then here you can see even the x not equal to 0 you are assuming that. So here again you have to assume that x is not equal to, at least x is not equal to n plus 1 times pi by 2 if c is equal to 0, if you assume. So first of all, whether x equal to 0 is in the domain of the solution, is it in the domain of the solution or not? So you can see that it is not in the this 0 is not in the domain, right? It is not in the domain. Although you can see x equal to 0, y is equal to, when you write y is equal to x times tan of minus c minus x, then x equal to 0, if you put, if you are assuming c equal to 0, if x equal to 0, if you put x equal to 0, then the solution will be y equal to 0. I mean, the solution will, the value of the solution will be 0, right? So the thing is, it was not clear while solving, but when you solve and you got y is equal to x time tan of minus c minus x, you see x equal to 0 satisfy, and you know this is the solution of the differential equation. Now, what way you came, that does not matter now, because x time tan of minus c minus x, that will be a solution whatever the value of x is, that you can check. So from there, what you can say, the x equal to 0 will be in the domain of the solution. So x equal to 0, at x equal to 0 also it satisfies this. That's what I wanted to tell you here. Okay. So other than that, few things you should remember, or I mean you should be clear about those. So d of xy should be x dy plus y dx. D of x over y will be y square, no, y dx minus x dy over y square. And you know d of x plus y, those are easy, right? Dx plus dy only, plus minus plus minus. So these things also you should remember. And another two method to find out the integrating factor also I said. del m del y minus del n del x, and this two, then most of the things will follow. I mean, you can follow most of the things. Okay, so yeah, there is another one interesting difference type of differential equation, which look like dy dx plus px times y is equal to some qx times y to the power n. This is called Bernoulli type differential equation. This is although little special, but it you can solve it very easily. You will always see what specialty is there. You will always see the integrating like integrating. For getting the integrating factor, you have to multiply. First of all, you have to substitute, you have to multiply by 1 over n, 1 over y to the power n, means y to the power minus n. And what you have to make it, you have to change the differential equation using the a variable change, which is nothing but 1 minus n, y z equal to y to the power 1 minus, and then what you will see, dz dx is nothing but y to the power, sorry, 1 minus n y to the power minus n, right? So, and if dz dx is this, you will see, if you multiply by y to the power minus n, it will be y to the power minus n times dy dx plus y to the power 1 minus n times px, right, is equal to qx. So what you find it from here, it will be 1 by 1 minus n times dz dx plus q times, sorry, p times z is equal to q. So now what I mean, you got the differential equation we already discussed. Means what we got, 1 by 1 minus n times dz dx plus p times z is equal to q. That implies dz dx plus 1 minus n is a constant anyway. Means it will be p prime sum z is equal to q prime. So the integrating factor will be e to the power p prime. So now it becomes easy. So this is well known form, right? When you have dy dx plus px times y is equal to qx, then integrating factor will be e to the power px, and we all know how to differentiate, how to get the solution. Already we have already discussed, right? So you can change the Bernoulli equation. So this is the Bernoulli equation. Bernoulli equation, okay? Bernoulli equation. Equals, okay? So this Bernoulli equation, you can change it to a very simpler from the simple first order differential equation, and then you can get the solution very easily. Yeah, so most of the things are done. I'll do my last question here from your assignment, and then we'll finish the class, okay?
Okay, so let's begin with the last question. So the question is from the assignment: sin y dy dx is equal to cos x time 2 cos y minus sin square x. So let me write this differential equation as, I keep sin y dy dx as it is, dy dx, okay, minus cos y times 2 sin x, okay, is equal to minus cos x sin square x, okay. So if I take why I wrote like this, so cos y is equal to z, then minus sin y dy dx will be dz dx, or sin y dy dx will be minus dz dx. So from here, if you substitute that, it will be minus dz dx minus 2 sin x times z will be equal to minus cos x sin square x, right? So that implies what we got is dz dx plus 2 sin x times z is will be equal to minus cos x, sorry, plus cos x sin square x. So if you take integrating factor will be e to the power minus 2 cos x, right? So z times e to the minus cos x will be equal to integration cos x sin square x e to the power minus 2 cos x. So you have to integrate it to get what is z, and if you have to put the value back, the z value you have to back it, okay. So it e to the power plus 2 cos x, sorry, e to the power plus 2 cos x, yes. Yeah, so this was cos x, so this will be total thing will be cos x. So here it will be also cos x, right? Cos x, so cos x, so it will be then sin x, it will be 2 sin x. So whatever is that, so that will be, you have to at the end you have to integrate. So integration over cos x sin square x times e to the power minus let me finish the calculation anyway. So it will be e to the power 2 sin x times sin square x cos x, right? That integration, and that integration is nothing but z times e to the power 2 sin x. That anyway it is fine, right? Z is equal to nothing but cos y times 2 sin x will be equal to this integration of dx is there, right? Okay, so you just integrate is like using separation of variable, I mean this part, integration by part. If you use integration by part, what will be this? So first of all, you take sin square x, then integration of e to the power 2 sin x, and then cos x dx minus integration of 2 sin x cos x times again this integration of
2 sin x cos x time integration of e to the power 2 sin x, again this quantity, right? But the integration of this quantity is nothing but, so sin square x times half e to the power 2 sin x, because the d of sin x you can write as cos x dx. So minus integration of 2 times sin x cos x times again half times e to the power 2 sin x. So that will be e to the power 2 sin x times half. So 1 2 will go. So another again, if you can, if you again do, so what will be this? So first quantity is 1 by 2 sin square x e to the power 2 sin x, and if you do another uh, another time this integration again, so it will be minus half sin x e to the power 2 sin x, plus the at the end you will get 1 1 by 4 times e to the power 2 sin x. So that will be the whole thing, and that is nothing but equal to cos y times e to the power 2 sin x. So that will be the solution for the differential equation we started with. Okay, the it is the last question of your assignment. Okay, so these are some books and references for your like for the reference to study, and then yeah, so thank you for your attention. I'll stop here for today, and we'll do in the next Saturday. We'll again, as usual, we'll have class. So this was your not usual class. I mean, it was rescheduled, and then we did it today. So the next class will be in the usual day. So we can like in next class will be on Saturday. So next class on Saturday. This Saturday only. This Saturday, I don't know what is the what is the date, I forgot, but the time this will be on Saturday, and then it will be on Sunday the next extra class Sunday from 9 to 11 a.m. and this will be this Saturday, it will be from 6 to 8 p.m. Okay, Saturday and Sunday. Okay, so we'll stop today up to this.